All right, welcome to section 521, the section we're looking at systems of nonlinear equations. And so for page 24, this page that we're currently on, this is two linear equations. So I'm going to have you guys do this on your own shortly, but we're going to do the nonlinear systems right now. So remember, these are systems now, so you do need answers for x and y. That's the biggest thing I want to recommend. All right, so our first one is 1/2 x squared plus 1 and then 2x minus 1. And so if you notice, they are systems. This is going to be a parabola, so it's nonlinear. That's why we call it nonlinear systems. And just remember, we had two methods to solve them for linear equations, substitution or elimination. And since they're both equal to y, I am going to use the substitution method where I'm ultimately just setting them equal to each other here. So that's where I'm going to start out at. I'm going to set them equal to each other. So I have 1/2 x squared plus 1 equals 2x plus 1. And so since I have a quadratic x squareds and x's, I am going to have to set it equal to 0 to solve. So I'd subtract 2x and then subtract 1. Oops, this was 2x minus 1. So this is plus 1. All right, so that gives me 1/2 x squared minus 2x and then plus 2. And that's equal to 0. Now the problem is I have this 1/2 in front. And if you think about our solving strategies, one of the strategies that we had was if we have a denominator, find a common denominator. Well, the only denominator is 2, so the common denominator would be 2. So if I multiply the entire equation by 2/1, I'm ultimately going to get rid of that fraction. Because 2/1 is 2, 1/2 is 2, 2/2 is 1. So 2 times 1/2 is just 1. So I'd have 1x squared, which is nice. 2 times negative 2x would be negative 4x. And 2 times 2 is plus 4. And that's equal to 0. And so now I can factor this with Sam. So that's going to be your trick for a lot of these. You are going to have to sum equals 0 and factor. So I have x and x. What multiplies a positive 4 but adds a negative 4 would be negative 2 and negative 2. And when I set each factor equal to 0, I'm going to get x equals 2 for both answers. Same answer twice. And so again, now we do have a system of equations. So there's x's and y's. So I have to find the y's, and again, I can just plug that x value of 2 into either of the equations for x and get the y. But the bottom one is going to be a little bit easier. So I have y equals 2 times 2 minus 1, or 3. Now, if this was a different x value, which most times you'll get a different x value, you would have to then plug that x value in and get another y value out, and that would be the ordered pair for the other point of intersection. But for right now, since it's the same, we are going to get the same answer. So we really only have one solution, which would be 2, 3. All right, so now what we're going to do, and it's kind of up to you. You can either graph these on your graphing calculator, make a table, or if these are equations that you already know, like you could graph them. So some of these I'm going to just graph on my own right now. So this is going to be a parabola that shifted up 1. And then I'm going to do my normal parabola. So I usually go right 1 and up 1, but I'm multiplying that by my a value of 1/2. So I'm going right 1 and up 1/2. And then I'm going to go 2 squared is 4. So I normally go over 2 and up 4, but now I'm doing half of that. So I'm going over 2 and up 2 from the vertex. And left 2 and up 2. I am going to do a couple more points. Let's do 9. Or sorry, my 3's. So I normally go over 3 and up 9, but I'm taking half of 9, which is 4.5. So I'm going to go from my vertex over 3 and up 4.5. 1, 2, 3, 4.5. And one more 2. If I did do 4's, it would be 16 and 8. I think this is going to be enough. So I'm just going to All right, so there is that one. Now this is going to just be a line. So that's y-intercept of -1 with a slope of 2. So I'm going to start at 0, -1, go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And then I'm going to go down 2, left 1, down 2, left 1. And what happens is they just barely touch right here. They touch at that one spot only. They come close at other spots, but they don't actually touch. So I have one. Remember, the solution is the point of intersection, so I only have one point of intersection right here, which is 2, 3. Also remember, if you're going to use your calculator, you can press second calc intersect to find the intersection point. But again, now we are using the x and the y values from the graph because our original problem had x's and y's. All right, as we go to our tables, we can just pull the points from our table. So this is -3, 5.5. And then our next point is -2, 3. -1, 1.5. 0, 1, 1, 1.5, 2, 3, and 3, 5.5. And then points we have for the line. We have -2, -5, -1, -3, 0, -1. 1, 1, 2, 3, and 3, 5. And so now if we're looking just at the table to try and find our intersection point, we're looking for where the x and the y are exactly the same. And we have a 2, 3 on this table and a 2, 3 on this table. So we know again that they are solutions there. All right, let's do one more example. So we can flip the page to the next one, page 26. And again, now we have a nonlinear system because it's a parabola and a line. And so again, if I solve this algebraically, they're both equal to y, so I can set them equal to each other. And I have x squares with x's, so I do have to get it equal to 0. So I have x squared minus x minus 2 equals 0, which again, I can Sam factor that. I'm saying what multiplies to -2 adds to -1 will be -2 positive 1. And I would set both of those factors equal to 0 and solve. So I get an answer of x equals 2 and x equals -1. Again, I'm not finished because my original problem has y values. So I have to plug in each of my x values into one of my equations. The bottom one's probably a little bit easier, and get the y values for each of those x values. Remember, it's really going to be the point of intersection in the end. So I have y equals 2 minus 2, which is 0. So one solution should be the x value of 2 gave us a y value of 0. So 2, 0 should be one point of intersection once we graph it. And then I plug -1 in. -1 minus 2 is -3. So my other intersection point should be -1, -3. And let's see if that works. Right, so again, these are fairly easily able to be graphed. So if there's something that's not easily able to be graphed, such as something in standard form, then you may want to use your calculator or Desmos to get the table. But in this case, these are pretty easy to graph, so I'm going to just graph them. So I'm starting at 0, -4 because this is a parabola move down 4. It has an a value of 1, so I'm just doing my normal pattern. Right 1, up 1, left 1, up 1. And then 2 squared is 4, so I'm going to go left 2 and up 4. And then we'll do the 3s. 3 squared is 9, so I'm going to go right 3 and up 9 from the vertex. And then left 3 and up 9 from the vertex. All right, so there is our parabola. And then we have our line, x minus 2. So this is starting at -2, going up 1 and up 1 and right 1. And then I'm also going to go left 1 and down 1. Again, remember we're looking for the intersection point. So intersection here and here. This is the point. Again, I need x's and y's because my original problem has x's and y's. -1, -3, and then 2, 0. These should match our algebraic solutions. And like magic, they do. Whew, man, so cool. All right, last thing we do is make our tables. So I'm just going to pull my points directly off the parabola. So -3, 5, -2, 0, -1, -3, 0, -4, 1, -3, 2, 0, and 3, 5. And that was the table for y equals x squared minus 4. And then y equals x minus 2 will be my right side, my right table, which I'll start at -2. So -2, -4, -1, -3, 0, -2, 1, -1, 0, 2. Oops, sorry, 2, 0. And then 3, 1. And again, the solutions from the table are going to be where the tables have the exact same points. So I have a 2, 0 in each table, and I also have a -1, -3 in each. And just remember that your table only shows integer x values. So if you had an x value as a point of intersection that's the decimal, which is definitely possible, it's not going to show up on the table. So I have -1, -3, and 2, 0. All right, there you have it.